incident light ray that landed on the, so this is called incident. The first light that is striking on the surface is called the incident light ray. Okay, so the incident light ray that landed on the surface is reflected off the surface. Okay, so the ray that bounces back is called as the reflected light ray. Okay, so incident light ray, this is a reflected light ray. So between these two, there is, between these two, incident and reflected light ray, there is an angle. This line is called as the normal. This line is called as the normal. So if a perpendicular line, so this is the perpendicular line, okay. So this perpendicular line that is being, the perpendicular line that is being drawn on the reflective surface, it is called as the normal. Okay, now this is the example of the reflection. So now you have 1 minute, guys. Hello. Yeah. Good evening, Gary. Really sorry, guys, for an important call. Screen is still visible, right? Or it got off?
Ma'am, it got off. Ma'am, when can we discuss the test results?
This is the last part of the chapter. We'll finish this and we'll start discussing. Okay. Okay. So now we're going. So in order for reflection to occur, so shadow cannot be formed every time. Similarly, reflection cannot be happening anytime. So there are certain laws that needs to be followed in order for reflection to occur. So we're going to see what are these laws of reflection. So the laws of reflection determine the reflection of the incident light on the reflecting surface. Okay, such as the mirrors, smooth metal surfaces, and all. So now, just think that there is a plane mirror. Okay, a plane mirror. So there is a light that is striking. What is this light that is falling called?
Incident ray light.
Incident light ray. Very good. And the one that is bouncing?
Reflected light ray.
Reflected light.
Reflected light ray. And the center?
Normal.
Perpendicular normal.
Okay, it's called the normal. Okay, and this angle is called as the what angle? Incident angle. This is called as the
Reflected angle.
reflected angle. Okay, so the incident ray, the reflected ray, and the normal so the first law is lie on the same plane. This is the first rule or the first law. You can see that it's not like incident is somewhere, normal is somewhere. It's not like that. It's not like this, right? It's all on the same single plane. It's happening all in one single plane. Okay. So it's the first law. Second, the angle of incidence is equals to angle of reflection. So these two angles are equal. All right. These two are the important laws of reflection. Okay. So when you're writing it down, please draw this diagram also and note it down. Only then it will be easy for you to study. Okay. Now we have something called the two types of not two, mainly three different types of reflection of light. The first one is regular reflection. It's also known as specular reflection. Second, you have diffused reflection. And finally, third, you have multiple reflection. We'll see each one of them in detail. Please note it down with the diagram. Tell me when you're done.
I'm done.
Okay. One minute. Good evening, Hridesh. Can you hear me? Hridesh, am I audible to you? Anvit, turn your camera on.
Yes, ma'am.
Okay, Hridesh, were you on time to class? Why were you late today?
Teacher, actually, I have some laptop issue.
Okay, fine. I have just taught a particular topic on light reflection. So the recorded sessions are there. So the first 5 to 10 minutes alone, it's there in the recorded session. You can just see it through that. Okay.
Okay, teacher.
I'm sharing my screen. Just copy down whatever I'm sharing on my screen on your notes quickly. And tell
Yes.
me when. Also turn your camera on. Tell me when you're done, guys. Don't take too much time. Also, don't be quiet. Just keep telling me when you're completed.
Ma'am and Divya completed.
Okay.
Ma'am, what is after same in the first point after the diagram? Incident reflected ray plus normal.
Lie on the same plane. Plane is the surface. They lie on the
Okay.
same surface.
Okay.
Ma'am, I'm done.
Okay. How many of you are left? All of you are completed? Can we go to the next topic?
Teacher, I'm writing.
Okay, okay. Take your time. Tell me when you're done.
Ma'am, this is Ritesh and done.
Okay.
Ma'am, this is subject completed.
Okay. Mommy, Mara.
Last three.
Okay, okay. Write it and then tell me.
Teacher Ridesh, here I have done.
Okay, good. I guess all of you are done, completed, yeah. Okay. Now we're going to see each type in detail. Okay. So first type, like regular or specular reflection. Okay. So specular reflection refers to a clear and sharp reflection. Okay, there's a perfect reflection. Okay, like there are incident rays falling. And equally, each ray is getting reflected properly. Okay, this is called as regular or specular reflection. So here you have a clear and sharp reflection. So like the ones you get in a mirror, you get a clear and sharp reflection in a mirror. So example, you have a mirror over here. Okay, so you know a mirror, what is a mirror made up of? A mirror is made up of a glass. Okay, so normal glass, we make glass, right? So it's made up of glass. It is coated with the uniform layer of a highly reflective material. So this reflective material is in a form of a powder. So mirror is glass plus reflective material that is in the state of a powder. All right, so this reflective surface, it reflects almost all the light incident uniformly. So this is uniform. You can see it's uniform. Okay, so there is no much variation in the angle. All the angles are like same. So no variation in the angles. Okay, this means that the haziness and the blurring are almost entirely eliminated. So there's no haziness. Haziness means reflecting like this, like this, like this. No, it's uniform. And blurriness, you know what is blurriness. So this is how a regular or specular reflection looks like. Is this clear?
Yes, ma'am.
Yes, ma'am.
Anybody has a doubt?
No, ma'am.
Yes, ma'am. Ma'am, whenever a ray, incident ray is fallen in a regular mirror, exactly at how many degrees angle will it? Is it like a specified angle or?
No, it's not like that. It's not like that. It's just reflected in such a way that the angle between the incident and the reflective surface should be same. Means you itself think this is 90 degrees. Okay. So here, if this is 45, this is also 45. If this is 60, this is also 60.
Okay.
Okay, you just know that the incident and the reflective surface is the same. Now, for example, you might get a sum like this. They might ask you, or they might tell you that if the reflective surface is 40 degrees, what is the angle? Sorry, reflective angle is 40 degrees. What is the reflective angle of the incidence light? What is it? What will if angle R is equals to 40, what will angle I be?
Ma'am, 40.
40 only. Why? Because it follows the law of reflection. Okay. Now going to the second type, we have diffused reflection. So reflective surface other than mirrors, they generally have a very rough finish. It might be very scratchy behind. Okay, so this may be due to like wear and tear. You know, you must have seen scratches behind the mirrors or dense dirt and all on the surface. So sometimes even the material of which the surface that is made might not be proper or good material glass. So all this will lead to the loss of brightness and the quality of reflection. So in that case of such a rough surface, what will happen? The angle of reflection when compared between points, compared between like 2 points, it is completely half a set. Like there's a reflective surface like this. This is all, I'm doing this on a mirror. Okay, wait. This is all happening in a mirror. Okay. Similarly, again, there's a mirror. But in a diffuse state, how will the reflection be? This is how your reflection will be. Can you see the difference? The wide variety of difference between normal specular reflection and diffuse reflection. Okay, so this will be in a haphazard manner. So it's not uniform. Okay, so for rough surfaces, the ray incident like at slightly different points on the surface is reflected in completely different directions. Okay, so this types of reflection is called diffuse reflection and is what enables us to see non-shiny objects. Okay, so this diffuse reflection will help you see these non-shiny objects. Okay, I made one mistake over here. Always remember the incident light will never ever change. So the source on the incident light will always be straight. The reflection only will be in a haphazard manner. Okay, I hope it is clear. Okay, so this type of reflection, so always this diffuse type of reflection enables us to see what? See? Non-shiny objects. And when does this diffuse reflection occurs? It occurs when surfaces
When the surface is rough.
are rough, when there is no finishing, or there is scratches, or there is dust particles. So all this, if it's there, all this will happen. Okay. And also if material used is not of good quality. Okay. Is diffuse reflection clear? Anybody has a doubt?
No, ma'am.
Okay. So going to the third type, which is multiple reflection. So a single image is formed when an object is placed in front of a mirror. You know that clearly. When you keep an object, not 100 images are not formed, just one image that is formed. So what will happen if we use two mirrors? So you must have seen in a dressing room, you can see hundreds of yourself. Have you noticed that?
Ma'am, in my barber shop, yes, ma'am, I saw so two big mirrors. They were just facing each other. I saw myself so many times.
Yes. So in this case, what will happen is you will have like two reflective surfaces. So what will happen? This is the light source, for example. Okay, so the light is entering from here. Okay, So this is, look carefully, this is the incident light. Okay, so this incident light is reflecting here again. So the incident light, this is mirror A and this is mirror B. Okay, look carefully. So now this red line is the incident line for mirror A, but the blue line is the incident or reflected light for mirror A.
Reflected.
Reflected. But the blue light is incident light ray for mirror B. Do you get it?
Yes, ma'am.
Yeah.
Yes.
So again from here it will reflect back here, or it can reflect in any uniform direction. This will again happen.
Ma'am, then it's like an infinity mirror.
Exactly. Exactly.
It will be
So
teacher.
it keeps on reflecting again and again and again. It will keep on reflecting. It will not stop. So this is more like an infinity mirror. So reflection.
It's like maze.
Exactly. So it's like multiple. That's why it's called multiple reflection. Okay. So listen carefully. So since reflective surfaces such as mirrors, they have a very good, preserving the intensity of light and reflection. So a single light source, it can be reflected so many times. Just one light source itself can be reflected so many times. Now, for example, just one, you have two mirrors. You have two mirrors.
Ma'am,
And
what
there
if
is,
they
what if they?
what if there were four mirrors?
Sorry?
Like if all the sides are covered with mirrors,
Yeah,
when
similarly, same thing. Reflection will happen in all the four mirrors. In gym and all, if you go and see, they will have all side mirrors. Okay, so that will also continuously happen. Okay, two or more mirrors, it will cause multiple reflection. So for example, just one light ray is falling, not so many, just one. This one itself will reflect so many times. Again it will reflect, again it will reflect, again it will reflect, again it will reflect. It will keep on going like that. Just one single light ray, that is the magic of multiple reflection. One single light ray can cause multiple reflection. Okay, so these multiple reflections, so I'll just write that point over here. Okay, so these multiple reflection is possible until the intensity of the light becomes low to a point that it cannot be seen. Okay, like you must have seen that you can now in a mirror, you go to a dressing room or you're seeing your image 100 times, you cannot see beyond one particular point. You can see only darkness. It will be very dark. Light will get dimmer and dimmer and dimmer and dimmer. Have you noticed that? Yeah. So that, why does it get dimmer? So this multiple reflection is possible continuously until the intensity of the light becomes low. That is why you can see it only to a one particular instinct and you can't see beyond that. Okay, so this means that we can have like almost infinite multiple reflections. Okay, we can also see an image in an every individual reflection. This means that each image is the result of an image or an image of an image. So first you're keeping an object here and keeping an object here. This object is again reflected over here. This object is again reflected over here. This object is again reflected over here. That is how it is. This is how it goes on.
Teacher, I saw in this fitting room.
Yes, exactly. That's why in the dressing room, in the fitting room, you can clearly see this example. Okay.
False.
Okay. So the number of images that we see, it depends on the angle of the two mirrors. If two mirrors are placed parallelly, like this parallelly between each other, you can see infinite images. But at the same time, if they are placed like this or like this, you can see only for a limited extent. The reflection will not be perfect. Okay. You can, now for example, you're keeping a ball over here. You can see something form like this only. Okay. You won't see a particular image. The angle the mirror is being placed is very, very important. Okay, so we can see that as the angle decreases between the mirror, the number of image increases. So the angle decreases, number of images increases. This is always the phenomena. Okay, so and when the angle becomes zero, like when that basically when does the angle become zero? When the mirrors are parallel to each other, that is when the angle is zero. So the number of images will become infinite. Okay, this effect can be easily observed when you're obviously when your barber uses a small mirror to show you the back of your head. You can see this is happening. Okay, so you can even see the this happening in your changing rooms and everything. So there's a formula for finding how many images can be formed. So number of images is equals to 360 degrees minus angle between the mirrors. This is very important formula. You might even have sums to do. Okay. So with this, we have successfully completed our chapter. Please make note of it. After you all are done, wait 1 minute. I'll just maybe increase the font. After you all are done, we'll start discussing the test answers. Yeah, I hope everything is visible now. Please make note of it. If there's any doubt, please ask me. And tell me when all of you are done.
I'm done.
Okay.
Ma'am, in first one last point.
Sorry.
In first one last point.
No haziness or blurring. Are you guys done? Make it quick, please.
Ma'am, I'm done.
Okay. Who else is writing?
Ma'am,
I done.
that I'm
Ma'am, I
done.
Teacher, I am done, teacher.
All of you are done.
Yes, teacher.
Ma'am, 1 minute.
Yes, ma'am.
Yes, teacher. Myros.
Please note down the homework. We'll discuss the test results tomorrow, okay? I have to go for the next class. Okay, whoever is done noting down the homework and everything on the board can leave the class.
Ma'am, can I leave? I'm done.
Teacher, I have done. Can I leave?
Yeah, you can leave it done.
Okay, ma'am.
Teacher, can you remove me? I'm not able to.
Yeah, I will let everybody leave. I'll remove.
Bye, ma'am.
Bye bye.
Ma'am, can you share your screen?
Teacher, can you remove me?
Yeah, I'll remove them.
Bye, ma'am.
Bye. Shritesh, are you done? Are you done, Shritesh?